Hi there guys, today we're going to hot plate reflow a ESP32. We're going to need a few things for this. First off, some acetone and some cotton pads just to wipe down the board and make sure we get all residue and oil off it. Then some solder paste. This came in this sort of format, but I've put it into this handy syringe. You can get these and then nozzles off Banggood or any of these sites for a very reasonable price. They're quite useful. And then some toilet paper to wipe it down. Once we're done, we're going to test the board with this multimeter to make sure that we've done everything right. Removing all oil and residue is very important to make sure that the solder flows properly. Here you just wet a pad with some acetone and then rub the pads quite vigorously. Just ensures that there's no gunk left on here to cause us any issues. I'm going to wipe the bottom of the module also because I've been touching it with my fingers and that could cause problems. Right, the next step is to apply the solder paste itself, so I'm going to zoom in here and get you guys a good view. Here it's important to ensure that you get an even amount of solder on each of the pads. This often will spread out as you heat it up, but it's good to have consistency. So I'm going to go ahead and put a little bit on each of these guys, trying to keep it even. If we find there's too little, we can always touch it up with a soldering iron afterwards. One of the main reasons we're doing this is this big heat sink in the middle here. I take it that that's going to pull some heat away from the processor into the test board, which is a good thing. You'll notice here that these bits are actually touching each other. That doesn't really matter. As the solder melts, the surface tension pulls it into boards, it wicks onto the pads, and there shouldn't be any bridges after this is melted, but we'll check with the multimeter afterwards. So after we're happy that we have a consistent amount on each pad, it's looking reasonably good. Don't really know how much to use here, but it looks alright. I'm going to add a nice dollop to the middle here and spread it out a bit. So that's looking good. Next step is to put the module on. These wide modules are quite hard to hold with a pair of tweezers, so I've got it hanging over the edge of this box just to help me in the positioning of the module. So I'm going to place it down gently on top of the solder here. You don't need to push it or tap it down. The surface tension of the solder will pull it towards itself when it's reflowing. Alright, it's off to the stove. I've had to do a bit of a balancing act here to ensure that you guys can see into the pot, but this is just a regular cast iron pot. To work out what temperature your solder melts at is a bit of a trial and error experiment. I found that Mark 4 on my stove works, but results may vary wildly depending on your setup and configuration. It shouldn't take very long at all for the solder to flow, so carefully and gently you pop it in to the heat and hope for the best. You'll see immediately that along the line of the solder it's all sort of formed a homogeneous stripe. That's because the flux in the solder is melted, but very quickly it will start to bubble, and then when it gets really shiny, that's when it's 100% melted, and it should suck up into individual balls on each of the pads, and that's exactly what we're looking for. If this doesn't work or takes too long to heat up, I often put the lid on just to make sure. So we'll give it a second and see. I think it's lid time. This normally doesn't take long. A few seconds at most, depending on the temperature you've set it. I am being overly cautious with this and don't want to get it too hot. So we're being careful here. This is one of the beta units. There we go. It's completely flowed. I'm going to give it another few seconds just to make sure. But as you can see, the solder has wicked onto each of these little pads as it's flowed. I'm going to give this a tiny little tap down on each of the corners, just to be sure. But I think we've won here. Right. So now that that's all nice and melted, it's time to take it out and let it cool. It's suggested that you let it cool reasonably slowly. You don't want to be introducing any stress to this, so I normally just put it up on the side of the pot for a little while to cool down there. I've taken a look at this very carefully and the joins look exceptionally good. You can see that there's no visible bridges along these gaps, so it's really looking good. We're gonna quickly do an electrical test now to see if any of these things are bridged, and the easiest way to do this is with a simple multimeter. You put it onto continuity mode and then just walk your way down the pins. If any of them were to be joined, there's a quick and easy way to sort that out, but I'll do a tutorial for that in potentially another video. So all of the pins are good. I'm going to do a final check on the actual pads, just to be 100% sure, because, well, this is a beta model and if I stuff this up, things are bad. So no bridges thus far. Next step is to solder in the pins. Here, to make my life easy, I've put the pin headers in a breadboard just to make sure it holds them straight, so that's going to make it a little bit quicker to do this. I'm going to set a soldering iron to about 310, and here we go. Again, we don't want any bridges here, so I'm going to do this quickly and carefully. Those are all looking good. So I've just done a final electrical check and everything checks out. No bridges, no issues whatsoever. So I think I'm going to try fire this thing up and see what happens. Right, so we've got it all wired up. We have a UART SB4. I found this to be one of the most trusty UART guys around. I also have one of these handy 3.3 and 5 volt breadboard power supplies. I've hooked this up with ground 3.3 volts to the 3.3 volt pin, and then enable I've pulled high with a 10k resistor, and I have a little push button here that grounds it, so that's effectively the reset switch for this. I then connected RX to TX, TX to RX, and ground to my FTDI also. So I've got Minicom set up in a Linux VM here, and I'm going to plug this in and see what happens. Holding out hope here. We have win. We can see here that it's coming up as a AP also, and I'm going to get playing with this and do some more tests and see where we can go. But thanks to Expressive for sending me one of these. I'm going to have a lot of fun playing with this, and I hope to post some more videos soon. Cheers guys.